This is Unit 3, Moles and Stoichiometry, Lesson 9, Naming and Formula Writing for Tertiary Compounds. How do we name and write formulas for tertiary compounds? By the end of this video, you will be able to identify tertiary compounds containing polyatomic ions by name, and you will be able to construct chemical formulas for tertiary compounds containing polyatomic ions. So do now. A tertiary compound is when compounds have more than two elements. It contains a polyatomic ion on table E. So you should have your reference table out and open to table E. Polyatomic ions are a group of two or more atoms that are bonded very strongly and act as one ion. They bond with other ions to form compounds. So for example, NO3, this nitrogen and oxygen, they combine very strongly in this ratio, and as a result, they have a -1 charge. This whole compound can then bind with a metal to form another compound. So to name them, we're going to follow the same rules as naming binary compounds, except the polyatomic ions on table E are named according to the table. So really, you're just going to have to look on table E and find the correct name. So in this case, we have sodium, Na. NO3, you'll look on table E and you'll find NO3 is nitrate. So sodium nitrate. So here are some more examples. We have CaCO3. We know it's a tertiary because there are 3 capital letters. Look on table E to find the polyatomic ion, and you'll see it's carbonate right here. So we'll have calcium carbonate. LiClO, we have 3 capital letters. So look on table E and find the polyatomic ion. You'll see ClO2 is right here, which is chlorite. So it'll be lithium chlorite. NaOH, 3 capital letters. So look on table E to find the polyatomic ion. You'll see OH is right here, which is hydroxide. So we have sodium hydroxide. And here we have 4 capital letters. So that means we have 2 polyatomics. So NH4, you'll see is right here. We have ammonium. And then PO4, you'll find right over here is phosphate. So we have ammonium phosphate. So writing formulas containing polyatomic ions is the same as binary compounds, except we're never going to change the polyatomic ion subscripts. If it's in table E, you're going to leave it just like that. If we have more than one polyatomic ion, you need to put it in parentheses, followed by a subscript. For example, write the formula for ammonium chloride. So we have ammonium right here is NH4, and chloride we know is Cl. So we're going to follow our same crisscross and reduce. So NH4 has a +1. Chlorine has a -1. If we crisscross, we're just going to get NH4 as 1 unit, Cl. So here's that out written so you can check your work. Write the formula for lithium carbonate. So carbonate is going to be found right here on table E. It is a CO3 with a -2 charge. Lithium you'll find on the reference table is in group 1, so that means it has a +1 charge. We'll do our crisscross and reduce. So we'll crisscross. Lithium is now 2, and then carbonate is still 1, so we'll leave it as is. Notice that the subscript 3, this one right here, in a lithium carbonate does not change. I left the CO3 as is. Write the formula for calcium sulfate. So we have calcium, we know as Ca. It's in group 2, so it has a +2 charge. Sulfate you'll find on reference table E is over here, SO4 2-. So SO4, 2, is it a 2-? 2-. So if we drop our charges, crisscross and reduce, we'll have CaSO4. Oh, that's the wrong. Oh, it should be phosphate. Huh. Well, look. Okay, look at this example. This was the wrong word. Calcium phosphate. We have a +2 charge, and PO4, if you look on table E, has a -3 charge. I'll crisscross and reduce. So calcium has a 3. Phosphate, I'm going to leave the whole group together and put it in parentheses and write the 2. So try some, check your understanding. And now you are able to identify tertiary compounds containing polyatomic ions by name, and you are able to construct chemical formulas for tertiary compounds containing polyatomic ions.